I welcome everyone to this video where we're looking here at interesting aspects of geometric series. I have two cases A and B. Look at the difference. A, n equals 0 up to infinity, 1 over a to the n. Look at B, n equals 0 up to infinity, I have minus 1 to the power of n divided by a to the power of n. In each of these cases you're looking at something in terms of a series which would have looked something like this. N equals 0 up to infinity. In general form you're looking at something like this where a is equal to that constant as you see. You're familiar with this. This is a geometric series. But we will examine these one by one and I'll show you some interesting concepts and shortcuts which arise with each of these forms. When you're looking at a geometric series, you have some immediate shortcuts available. When you are looking here at case A, let's start with that. If you were to expand this out, what will you have? You will have 1 over a exponent 0 plus 1 over a to the 1 plus 1 over a square plus 1 over a cube onwards. You only have positive terms. Then you're worrying about a common ratio. Your common ratio is always a number divided by a number before. When you're looking at this, your common ratio would be something like this. You're doing 1 over a to the power of n divided by 1 over a to the power of n minus 1. The item you see over here is your common ratio if you just remove the exponent. Exactly what I see over here, 1 over a should be my common ratio, and I'll show it to you. Do the division of these two. You have a to the n minus 1 divided by a to the n. The laws of exponents. A to the power of n minus 1 times a to the power of minus n, and you are doing basic algebra here. A to the n minus 1 minus n, same basis exponents add. These will cancel out. You'll have a to the power of minus 1, which is 1 over a, which is exactly what I already clued you in. My common ratio is exactly what I see right over here, but we're focusing here on the series A. So I know for series A my ratio is 1 over a. If you know that the absolute value of that common ratio is less than 1, a value less than 1, it's convergent. You'll have a finite sum of series, because in this video we're going to determine the sum of series for each of these. If this is the case as you're seeing over here, your common ratio is less than 1, you have a formula, the first term divided by 1 minus r. That's exactly what we'll do. My first term is this, which is equal to 1 over 1 minus my common ratio, which is a 1 over a. Do fraction algebra. I have 1 over a minus 1 over a. Flip things around, I have a over a minus 1. I know for this particular case right here, a, let's bring it out for you over here, then we can formalize it. I know for case A, my sum of infinite series for this particular geometric series will be equal to a over a minus 1. I also know my common ratio will be equal to 1 over a. So let's show you a quick example using these findings we have determined. Imagine our example was just this. We're looking from n is equal to 0 up to infinity. I have 1 over 3 to the power of n. I know just by looking at this, my common ratio is equal to 1 over 3. It's 1 over a. My sum of series will be equal to what? Here I know a is equal to 3, the constant. It'll be run everything to that formula. 3 over 3 minus 1. It'll be equal to 3 over 2. So we know we've established that, and it's good. This right here pertains everything to case A. So case A is done. At the end of this video, we'll bring everything in a formalized manner. Look over here at case B, it's slightly different. It's n equals 0 up to infinity, a certain sum, but it's minus 1 to the power of n divided by a to the power of n. In this particular case, if you were to expand it out, you have alternating positive and negative terms. You will see, as you expand it, you'll have minus 1 to the power of 0 divided by a to the power of 0. Then you have minus 1 to the power of 1 divided by a to the 1. Then you have minus 1 squared divided by a squared. Then you have minus 1 cube over a cube. And you can keep going. When you open it up, you'll see that you have a 1. This right here would be equal to 1. Then you'll have a minus 1 over a. Then you'll have a plus 1 over a squared. Then you'll have a minus 1 over a cube. Then plus 1 over a to the 4. Minus 1 over a to the 5. And plus on and on. That's what you would have. You're seeing alternating positive and negative terms. In this particular case, when you see something like this and you know it's a geometric series, your common ratio is equal to what you see over here but with a minus. And why is that the case? Run everything through what you see over here. Pick a term and pick this term right before. And we don't even have to give it exact numerical values. We're looking here at minus 1 over a to the n. And the term before it is a positive, it will be 1 over a to the n minus 1. Bring everything here in terms of the fraction algebra. A to the n minus 1 divided by minus a to the n. That's what you have. You flip things around, this is what you have. You can push the minus right here on the side if you want. When you look at this, you bring this up, you're looking at a minus, then you have a to the n minus 1 times a to the minus n. And then you're looking at a minus sitting outside. You have same basis exponents add. You have a to the minus 1. When you bring everything together, you have minus 1 over a, which is your common ratio as we've already determined. And if we are assuming here the common ratio is less than 1, the absolute value, because it will go to the absolute value, then you can still use that formula, the sum of infinite series is equal to your first term divided by 1 minus r. Let's bring everything through here. You know your first term is already highlighted. When you have n equals 0, for these type of geometric series, your first term is almost always a 1. Unless you had a constant here on the top, but we don't. Here I know for this, I'm looking at a 1 divided by 1 minus, and my common ratio is a minus 1 over here. Now you'll see something particular, a positive will come over here. You'll have 1 over 1 plus 1 over a. When you take this to completion, you'll have a 1 over a plus 1 over a. If you take it further, you have a over a plus 1. If you compare this with this, you see the difference. Here your denominator value is smaller, here your denominator value is larger, which tells you what? If I'm comparing the sum of series, let's say for case B versus the sum of infinite series for case A, the sum here will be larger than B, because here you only have positive terms. Adding here you have alternating positive and negative terms. The negative terms take away from the total sum of that series, and this becomes a smaller value than that. So now we've established two more items for case B, and let's publish them for you over here. Then we look here at an example. Before I do that, let's show you a quick example. If I'm looking at something like this, n equals 0 up to infinity, I have minus 1 to the power of n divided by 5 to the power of n. I know here my common ratio is minus 1 over 5. I know here my a value is equal to 5. But I don't need to do any work, I have a formula. My formula here for sum of series, infinite series for this, as you see, would be 5 over 5 plus, it would be 5 over 6. That's what it would be. Anyhow, let's conclude this video with a good concrete example which will clearly compare both of these. I've put everything you need to know over here. For something which looks like this right here is your sum of series a over a minus 1, where you only have positive terms, your common ratio is 1 over a. When you have alternating positive negative terms, your sum of series is smaller value, a over a plus 1. The denominator here is larger than here, so the sum here is smaller. Common ratio is minus 1 over a. But let's close this video out with this example. I'm looking over here from n is equal to 0 up to infinity. I have over here 1 over 7 to the power of n. I'm looking here at this other example, which will be almost the same. 0 up to infinity, I have minus 1 to the power of n divided by 7 to the power of n. Here I know my common ratio is equal to 1 over 7. I know my a is equal to 7. My sum for this series, this geometric series, will be running through this formula. It will be a 7 over 7 minus 1, which is a 7 over 6. It will be larger than this. Here I know my common ratio is minus 1 over 7. My formula here for the sum of this series, a geometric series with alternating positive and negative terms, will be smaller than this, because those negative terms will take away from the overall value, overall sum. It will be going by that. I know a is equal to 7. It will be 7 over 7 plus 1. It will be equal to 7 over 8. What is larger? 7 over 6 is larger than 7 over 8. You can run this on your calculator. But these are two examples. Here's your one example, here's your other example. The sum for this is a 7 over 6. The sum for this right here is a 7 over 8. But keep in mind what I've shown you here. You look at something like this, here's your sum for that series. You look at something like this, here's your formula for that sum. That's it. Thank you for watching.